Greetings, ladies and gentlemen, my name is Cam the Man and welcome to another video on my math channel. Hello. So today we are going to be talking about a very large concept that is very important if you want to get into other more advanced maths. It's also a concept that many people do not like, and that concept is quadratics. Quadratics, there we go. So a lot of people don't like this concept because it has a really complicated formula. But I'm going to be showing you several different ways to solve a quadratic equation, which is ax squared plus bx plus c equals 0. I'm going to show you several different ways to solve a quadratic equation like that. And yeah, let's just get right into it, shall we? Okie dokie, we're back with this question. What are quadratics? So most of you watching this video probably don't even know what they are, so I'm going to be telling you what they are. Quadratics are any equation where x is to the second power. So, for example, let's do x squared plus 13 minus 2 equals 0. This would be a quadratic equation because x is to the second power, right there. So another way that you can tell quadratics, even when it doesn't give you a formula, is when it is a curved graph. Looks something like that. So there's your graph, and then it curves like that.
As long as it has that U-shaped curve, it can be either like that, or like that, or like, yeah, like that. Then that's a quadratic with the curved graph, because when you square something, it makes it a negative, it makes it positive, because it's squared, and it will eventually start to go back down, and making that curve there.
Okay, so that brings us to our next question with how are quadratics used? And quadratics can be used anywhere from finding the dimensions of a box to, measuring how high or much a baseball will bounce after it's thrown or something. Measuring, and it's just used in math class and stuff. And there are many ways you could use them in real life. I won't cover all of them here, but I will give you an example of at least this one later in the video. Okay, that brings us right into our next topic of how can you solve a quadratic equation. Okay, so simple problems with x being used only one time in the equation can be solved by taking the square root. Basically, you do this by simplifying the equation down to where it says something like x squared equals y, and then find the positive or negative square root of y. So let's do an example of that real quick here. So we have 2x squared plus 3 equals 75. So what you would have to do to do this, like I said, is simplify the equation down to where it says x squared equals y. So to do that, then you would subtract 3 from both sides to get 72, and then you would get 2x equals 72, or 2x squared, sorry, 2x squared equals 72. And you divide by 2 on both sides to eliminate that. And you would get x squared equals 36. And then at this point, then you would have to try to get x alone, of course, to find the value of it. So you would have to undo this square there. And to do that, then you would slash it on this side, and then you would find the square root of this number. So we would have x equals positive or negative square root of 36, which is either positive 6 or negative 6. So x is either equal to negative 6 or x is equal to positive 6. It could be either one of these right there, but of course, as with all of our equations, we have to check our answer. So let's do a proof over here. Proof. There we go. Let's plug them into the equation. So we have 2 times 6 squared plus 3 equals 75. So 6 squared is 36. So 2 times 36 plus 3 equals 75. As we established earlier over here, then 2 times 36 is 72, plus 3 equals 75, which is a true statement. 72 plus 3 is 75, and 75 is equal to 75, so our equation checks out. We can also do the other one. So we would have 2 times negative 6 squared plus 3 equals 75. And a negative 6 squared would also make a positive 36. Then we would have 36 again. And then it would be the same thing as up there, with 2 times 36 equaling 72, and 72 plus 3 equaling 75, and 75 being equal to 75, meaning that our equation does indeed check out. Alright, that brings us to our next one, which is another way to solve a quadratic equation. Because that one only works for where there's only one value of x, it's very limited to what quadratic equations you can actually solve with that. So more advanced problems with more than one x can be solved by factoring. And this method is actually better explained by showing you instead of just telling you how to do it first. So that's what I'll do. I'll do an example for you. So let's say x squared minus 12x plus 27 equals 0. 27 equals 0. Now just a side note for these problems, if that doesn't equal 0, if you want to factor it properly, make that equal 0. So if that's at like 48, then you'd subtract 48 from both sides to make that 0. Okay, so here's the thing with factoring. Okay, so this might be a confusing way to explain it at first, but here's basically what I have. So let's do f plus g equals b, and fg equals c. So this doesn't really make sense unless you look at the actual equation, which would be, if you just look at, you strip all the numbers from it. So that would be a x squared plus, or in this case minus, b x plus c equals 0. So this b here is what that would equal, and this c here is that, and then f and g aren't even in this equation. It's just variables that aren't actually assigned to anything already. So they can actually be anything. So basically what you need to do for this factoring is you need to find out what f and g are. So f plus g equals negative 12, and f times g equals 27. And then you would need to find the two numbers that f and g would represent when added together would equal negative 12, and when multiplied together that would be 27. Hopefully that when you look at the equation more closely, then you'll notice that negative 3 and negative 9 fit the bill, because negative 3 minus 9 is equal to negative 12, and negative 3 times negative 9 is equal to 27. So therefore the f here, the f has to equal negative 3, and the g has to equal negative 9. Okay, now we can pretty much, if you look at it more closely, now that we have those values, we can pretty much replace this entire beginning of the equation with x minus 3 times x minus 9 equals 0. So in order for these multiplications to be 0, then either one of these or both of these has to be 0. So for this equation to work out, what we'd have to do is we'd have to solve for both of them individually. So let's do x minus 3 equals 0. Add 3 to both sides to get x equals 3. And then on the other one, then we would do x minus 9 equals 0. You would add 9 to both sides to find out that x equals 9. So it could be either one of these, as you'll see when we do our proof. Okay, so now let's do the proof for that equation. If you forgot what it was when I deleted it, that's my fault. But it was x squared minus 12x plus 27 equals 0. That was the equation. And what we got for x was -3 or -9. Sorry for my sideways writing there. Okay, so let's do our proof here. So let's do -3 squared minus 12 times -3 plus 27 equals 0. Let's just do this first. So 9 minus 12 times -3 plus 27 equals 0. Let's do this 12 times -3 here really quick over to here. That would be sorry, that's -12 times -3, so it would be 36 plus 27. So let's do 9 minus 36. Which would get you -27. And -7 plus 27 is, of course, 0, which equals 0. So that checks out. And if we plug in the other one, so let's do -9 squared minus 12 times -9 minus 12 times -9 plus 27 equals 0. Let's try doing that. So -9 squared would give you a positive 81. Let's do this math over here. So 12 times 9 would be 18, 10, 108. So 108 plus 27 equals 0. Which would give us a -27 plus 27 equals 0. That would be 0, which equals 0. And so our equation checks out for that one as well. Actually, I just realized my mistake on the past problem. The x is equal to 3 and 9, not -3 and -9. That was a mistake on my part. I apologize. I solved the equation wrong there. But you'll find that you'll get the same answers if you do the positives. I just didn't solve them right when they were in the negatives. Okay, so anyway, that's all good for some problems. But what if x squared has a number that's being multiplied by? So for example, like 2x squared or 3x squared. Once again, this is better explained by showing, so we'll do another example. Let's go up here, and this would be 2x squared minus 2x minus 180 equals 0. Let's do this one. So in order to solve this problem, you have to eliminate the 2 from the 2x. So in order to do that, you'd have to divide everything in this equation by 2. So let's divide this by 2, eliminate that. Divide this by 2, we can eliminate that. Divide this by 2, and divide this by 2. To get us x squared minus x minus 90 equals 0. There we go. So now we have a problem, because from here we would solve it by factoring, but there is no number before this x. So to do this problem, you would have to always remember that before this x, there's always going to be a 1, because anything times itself is itself, so it's always going to be a 1x. So now we can just solve it by factoring, and do, I believe I called it g and h, so g plus h equals -1, and g times h equals -90. You could solve this one, and hopefully -10 and +9 jump out to you, with g equaling -10 and h equaling +9. Okay, so now that that's all done, we can just solve it by factoring from there. So x minus 10 times x plus 9. And then we would solve it from there with x minus 10 equaling 0, which would mean x equals 10. And also for x plus 9 equaling 0, which means x equals -9. It could be either one of these here. Okay, so now let's do our proof. As you can see, I actually remembered to write my equations up there this time. That's better than last time. I don't mess up whether they're positive or negative or anything. So yeah, now let's just do the proof and apply it. So we have 2 times 10 squared minus 2 times 10 minus 180 equaling 0. So once again, we'll solve this with 10 squared being 100, and 2 times 100 minus 2 times 10 minus 180 equals 0. 2 times 10 would be 20 minus 180 equals 0, and then we'll write the 2 times 100 over there. Whew, okay. That would be 200 minus 20 minus 180 equals 0. 200 minus 20 is 180. 180 minus 180 is equal to 0, which equals 0, and so our equation checks out. Okay, now we're going to do it again, this time with 2 times -9 minus 2 times -9 minus 180 equals 0. We'll do this one. So -9 squared. So -9 times -9 is positive 81. So 2 times 81 plus, because negative times negative is a positive, 18 minus 180 equals 0. 2 times 81, we'll do the math over here. 162 plus 18 minus 180 equals 0. 162 plus 18, we'll do the math over here. That will be 180. and 180 minus 180 is indeed equal to 0, and 0 is equal to 0, so that checks out as well. Okay, so now we're going to practice a few of these problems before moving on. So pause the video and try solving each problem yourself before looking at the explanation that I give. So yeah, we'll just start with problem number 1, which is x squared minus 4x plus 3 equals 0. So go ahead and pause the video now and try to solve this problem yourself. I'll give you 3 seconds. Alright, I'm assuming that you tried to solve this problem yourself, and now we will try to solve it. So in order to solve this problem, you have to factor, like I taught you before. So that would be g plus h equals -4, and g times h has to equal 3. So I hope that what jumps out at you for this is that g would equal -1, and h would equal -3, because -1 plus -3 gives you -4, and -1 times -3 gives you a +3. And then you can go over here and you can replace them. So we would have x minus 1 times x minus 3, like that, equals 0. Go over here, solve them both separately. X minus 1 equals 0, x minus 3 equals 0, giving you the final answers of x equals 1, or x equals 3. I'm not going to do the proof on these for time's sake, but if you want to pause the video and do the proof on these, then you'll find that it will check out. Okay, practice problem number 2. This will be x plus 3 squared minus 4 equals 0. So go ahead and pause the video now and try to solve this problem. Okay, so this one is actually kind of a trick question, but it's essentially just taking the square root problem. So you can use reasoning to figure this problem out. So you would add 4 to both sides. This would be your first step. So that would be x plus 3 squared equals 4. And then you would take the square root from this. So x plus 3 is equal to the positive or negative square root of 4, like that. So we would have x plus 3 equals 2, or x plus 3 equals -2. We would subtract 3 from this one and get -1. X equals -1 there. Or you would subtract 3 from both sides here, and you would get x equals a -5. Once again, I won't do the proof here for time's sake, but you can pause the video and check it, and you'll find out that it does check out. Alright, now it's time for the special challenge problem of the day, which is it's a real-world situation problem. Like I told you earlier how you can find dimensions of things. That will be what this problem is related to. It is based off of a box dimensions problem on Khan Academy, but it is not the same problem. Okay, so here it is. Okie dokie then, so here is our word problem. It says NASA is building a research building / habitat on Mars in the shape of a rectangular prism. The volume of the prism is 405 cubic meters. The height of the prism is x meters, the width is x plus 4 meters, and the length is 9 meters. The doors are in the middle to the longest sides, and windows are spaced out evenly about 1 meter apart from each other. Find the dimensions of the habitat. So a lot of times tests and things for school will throw out this kind of question at you. Basically it tells you all of this information that's important, and then tells you stuff that you don't even need to solve the problem. So who cares if the doors are in the middle? So that has nothing to do with the dimensions of the habitat. So So you can pretty much just forget that any of this ever existed. Okay. And now we're going to focus on finding the dimensions of the habitat. So, I don't know about you guys, but I learn better with a visual, so I will draw one. Let's just draw a rectangular prism here. Woo! That is the worst rectangular prism I think I've ever drawn in my life. Okie dokie. I'll just go ahead and erase that real quick. Actually, you know what we could do, actually, is we could just do this. There we go. Okay. Let's draw us a nice rectangular prism here. Okay, so there's our rectangular prism that represents our habitat. So the volume of the prism, as they told us up here, is 405 cubic meters. Always label your units. Okay, that was terrible, but whatever. Okay, the height is x meters. X is the height. The width is x plus 4 meters. And the length is 9 meters. Once again, label your units. Okay, and now we have to find the dimensions of the habitat. So the first step is to try to convert this problem to the quadratic formula. So this would be another issue that you would need in order to get into a high school, which would be to know how to write the equation from this. So the first thing is to convert it to the volume formula, which is V equals LWH, length times width times height. So let's do that real quick. So we would have the length, which is 9 meters, times the width, which is x plus 4 meters, times the height, which is x meters, equals 405. Now this looks kind of complicated the way that it's written right now, but really all that we have to do is just try to translate it to an easier way to understand. So we'll just, because of the commutative property, we can slide this x over there and give it a something that it's attached to. So we would have 9x times x plus 4 equals 405. This is looking a lot better to me. Don't know about you. And then this, if you were to distribute that 9x into the x and the 4, then you would get 9x squared plus 36x equals 405. This is starting to look more like the quadratic formula because it has the squared there and everything. However, if you remember the formula, ax squared plus bx plus c equals 0, then there has to be that 0 there. So we would subtract 405 from each side. And then we would have 9x squared plus 36x minus 405 equals 0. And then from there, then we can begin factoring. Second here. That's my notes. Okay. And then from there, then you can begin factoring. So once again, like we did in the last problem, you would divide everything by 9. And that would give us x squared plus that will give us x squared plus 4x minus 45 equals 0. And now we can solve it by normal factoring. So g plus h equals 4, and g times h equals negative 45. Go ahead and pause the video now and see if you can figure out some solution to what g and h could be in this. Okay, you should have discovered that g here should equal 9, and h should equal negative 5. And then we can plug this back in again, so we would have x plus 9 times x minus 5. So that would give you x equals negative 9 and x equals positive 5 as your little sub answers there, because we have to find the dimensions. But you're probably saying, hey Cam, what's up with all this? Because a box can't have two different sets of dimensions, which is true. So we have to think of this logically. In real life, no shape could have negative dimensions. So the one that we would have to choose to represent our box would be this one. And once again, if you did the proof though, you'd find out that both of them are correct. Okay, so now we're back here, ready to solve our problem, to plug 5 in for all of these. So the length we already know is 9 meters. The width is x plus 4 meters, x being 5. 5 plus 4 is 9 meters. And the height being x meters, which is 5 meters. And of course, the volume is equal to 405 meters cubed. And that, my friends, is your final answer. And it makes you very happy. Alright, so that was all fun and cute and stuff, and that last problem was a little bit hard. But, I mean, it's really not that bad. I thought quadratics were hard. Well, they're not really. But I only taught you part of them, still. It's going to be quite a long video because this is quite a large concept. So now let's get into the quadratic formula, which is what a lot of people think of as the harder part of quadratics, because it's a big formula and it's hard to memorize and stuff like that. So yeah, I'll just kick it off by writing down this highly, easy to remember formula here. Okay, so here it is, ladies and gentlemen. X equals negative b plus or minus the square root of b squared minus 4ac, and all of that is over 2a. So there you go, this is the harder part of quadratics, and once you look at it, it's actually quite simple. So we'll solve a problem with this. So this is used to solve problems that don't go into each other perfectly with the g and the h, like the ones that we can solve with factoring do. So of course try to solve it with factoring at first, and if you end up with some crazy stuff that you can't do, nothing matches for, then there you go. Mostly when you have a problem that you have to do this for, it'll tell you to round to something. For this one we're going to round to the nearest 2 decimal places. You'll also most likely be able to use a calculator on this, so we will do that as well. But not for the whole problem, of course. So here's the problem that we're going to be trying to solve today with this formula. So we have negative 6x squared minus 3x plus 4 equals 0. There we go, in all its glory. Once again, if you don't remember, this is ax squared plus bx plus c equals 0. So that's where the b's and the a's and the c's and stuff come in this formula. So the first step in this is to convert it to this formula. So x equals negative b, which is negative 3, and the negative of a negative is a positive. So x equals 3 plus or minus the square root of b squared, so negative 3 squared, minus 4 times a, which is negative 6, times c, which is 4. And all of that is over 2a, which is negative 6. And then from there we would just have to work through this problem. Alright, I'm back, and I got me a calculator. So yeah, the first thing you would want to do is solve this here. So we'll just start here with negative 4 times negative 6, which would give you positive 24. And then a positive 24 times this 4 here would give you positive 96. So let me get my pen here. Okay. So now we would have x equals 3 plus or minus the square root of negative 3 squared plus 96 over 2 times negative 6. Okay, now we're going to find the square root of negative 3, which is 9. And 9 plus 96 is going to be 105. So we're going to have x equals 3 plus or minus the square root of 105, and all of that is over 2 times negative 6. Okay, so now we're going to find the square root of 105. You should use a calculator for this because it would be quite difficult to find that. Because the square root is 10.246950077, which is why it tells you to round to the nearest 2 decimal places here. So that's what we're going to do. So it's approximately 10.25. So x equals 3 plus or minus 10.25 over 2 times negative 6. Okay. Now we're going to solve this both ways. So let's do 3 plus 10.25, which would give you 13.25. So x equals 13.25 over 2 times negative 6, or we could do minus 10.25. So let's do that. The calculator here, 10.25 minus 3. Oh, what did I just do? Okay. 10.25 minus 3 equals 7.25. Over here, so that would be x equals 7.25 over 2 times negative 6. La 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 la. There we go. And then we'll solve for this. So 2 times negative 6 is negative 12. So that would be 13.25 divided by negative 12, and 7.25 divided by negative 12. Since it's already up on my calculator, we'll start with this one over here. So 7.25 divided by negative 12 would give you negative 0.60416667. So basically it's just 0.6. So x equals negative 0.6 over there. And over here, 13.25 divided by a negative 12. We'll do that. 13.25 divided by negative 12 equals negative 1.1, approximately, of course. X equals negative 1.1. And there we go. Those are our two answers to solve this problem. Okay. So now I'm going to give you one of these problems to try to solve on your own, and then I will solve it after that as well. Alright, so here is my problem for you. This would be 9x squared plus 12x plus 4 equals 0. Go ahead and pause the video now and try to solve this problem. I will give you 3 seconds. Alright, we are back here with this problem here, trying to solve it. So once again, we're going to convert it to the formula. So x equals negative 12 plus or minus the square root of 12 squared minus 4 times 9 times 4. Here we go. And then let's go ahead and put all of that over 2 times 9. Alright, there we go. And let's work through this problem together. So 4 times 9, first off, is 36. And negative 36 times that 4 there is going to be negative 144. So now we have x equals negative 12 plus or minus the square root of 12 squared minus 144. And all of that is over, okay, let me get rid of that. Okay, all of that is over 2 times 9. Yeah, 2 times 9. Now 12 squared is 144. 144 minus 144 is 0. And the square root of 0 is just 0. So now our equation is negative 12 plus or minus 0 over 2 times 9. And of course, it doesn't matter whether you're adding or subtracting 0, it's still negative 12. So our equation is really x equals negative 12, just negative 12 over 2 times 9. 2 times 9 is 18, so that would be negative 12 divided by 18, which gives you a point, a lot of 6s. 6 repeating. So that's basically 6, 7. So that would be x equals negative 0.67 as your final answer for this problem. Voila! Thank you very, very much for watching this video. I really appreciate it. I really appreciate everyone watching these videos, and I hope you all enjoy. Please comment, subscribe, all of that stuff, and comment any questions that you have for your pre-algebra or algebra 1 problems, and I can help you solve math problems that look something like this. Okay. Anyway, thank you very much for watching, and this is Cam the Man going shabai bye. Shabai bye.